Today I will represent my final topic about embedded system. My topic is Ryuto project for controller, and my group include me and Đức Vinh and Đức Anh. And here is my group member. uh, for my final topic is in this topic, my group decided to build a Yocto environment then control it through Intel Galileo Central, and the project aimed to build a minimal Linux system. Use the Yocto project for control it. The objectives include config and build lightweight embedded Linux image, enable GPIO functionality in the Linux kernel, and develop a simple application to turn on the net on off, and understand the Yocto build workflow and the system customization and vision. The vision of this final topic is the build Yocto environment and control it through Intel Galileo Gen 2. Mm. So I will give overview about more Intel Galileo Gen 2 uh, overview. Intel Galileo Gen 2 is a Arduino compatible IoT board with the Intel Workshop 1400 megahertz and memory 250 mega RAM and 8 mega RAM flash, and support 32 micro SD connectivity, 20 GPIO Ethernet, USB, mini BCLE, I2C, and SPI. Advantage is easy to use, support Arduino cell, ideal for education and IoT application, smart home environment monitoring, eager DTS1 111 sensor to read temperature and humidity. Note this board is not uh, support so in this slide I will talk about the foundation of the Yocto project. So we need to know about Yocto means Yocto project is open source system that help developer create a custom Linux or Android operating system for embedded device. It's not a Linux distribution, but set a tool and process to build a operating system from scratch, including kernel, file system, and app. To allow easy to customization for specific hardware, which crucial in embedded system where hardware requirements vary greatly. And here is the main component of Yocto include the Poke. First is Poke, the reference of system that contain the build system and the metadata. And second is feedback, the task skill engine for the building image. Third is meta layer repository that provide configuration for recipe for different hardware, platform, and software, and recipe instruction how to build a software package, and layer collection of release recipe and configuration file and other data. And here is here is about the summary of the theory of Yocto project. And next, I will represent the uh, this part.
Next up is I will show you how to build a Intel Galileo Yocto. First, we need to understand the structure inside Yocto directory. So after you successfully downloading the Yocto source code, the directory structure should include bitbake, meta in Intel is Galileo Intel meta skeleton, meta Yocto BSV or short for board support package, and many other meta, and most importantly is meta bookie, where the extender layer for bookie that provide additional recipe and default configuration. Meta Yocto BSB contain board support package for specific hardware platform and script that assist with project management, and finally OE init build environment. It's just for initializing build environment, a script used to set up build environment. Next is the step-by-step to build Yocto in Ubuntu. First, you need to download your Yocto project through git clone by typing git clone git/git.yoctoproject.org/pocky. Next, you need to git check out the branch name that you want to use. Intel Galileo Yocto source have 3 branch, but it are the same author, so you can use any branch you want. Next is initializing the environment by going into your Pocky directory, then source initially build environment, then it will take you to the directory build. After you in the build directory, before you bitbake core image minimal, first you need to make your own meta layer by typing bitbake layer to create a layer, then that / your meta layer name. For example, in my Yocto build project, I add another layer that name meta /Đức Anh. Next up is you add the new layer to the system, so that when you bitbake core image minimal, it get added into the root system by typing bitbake add layer your meta layer, and the more important layer is open embedded system. Next is you create program inside your meta layer by going into your meta layer name directory, then make a directory through recipe/app. My Yocto project is make the LED blink, so I will name it blink. Then we go inside the directory blink, and through file we create a blink.c file. Through that we add the source blink inside that, then we go out to cd Pocky, then source initialize build environment again, then we go to the con/open directory called /local config. Inside the directory, we need to add this code image install Blink and machine Intel Galileo change 2. It depends. You can use Quark, Intel Quark. There's many name for the machine, but in the past, but now it's all end of life, so you cannot do Intel Galileo anymore. Next up, you in the directory of build, you type in bitbake core image minimal, and then this you will initializing building your image. Then this project take up to 30 minutes or 1 hour, depend on your computer. After it have been built, you need to flash image into your SD card by adding the SD card to your SD slot on your computer, or you use a standard USB that read SD card. By going to, after successfully build the Yocto environment, the image will be saved at Yocto Bokeh build TMP deploy image Intel Galileo Gen 2, and inside that you will see the image. Next, flash image. By locating the SD card, you type in the terminal SLSBLK. It will show you the list of directory, and you should see like your SD card on the branches. Next up, chưa có xong, quay lại đi. Next up is use sudo dd to initialize by copy the image in the before, then sudo dd temp the sudo again, then finally using the SD card. After that, you just put the SD card inside the Intel Galileo, then boot it up on another terminal. And here is our source code for Blinklet.
So this is my part, and I'm gonna describe and explain for you about the code to control LED. So this is Linux kernel module written in C language, and it's designed to control a LED connected to GPIO, which is the pin that on the module, making the LED blink on and off. So first of all, include first 5 lines are include headers, which is the library. First line is Linux module, which is provides a micro and function for creating a kernel module. The second line is Linux kernel, so it offers utilities like PR info for printing kernel logs. Next line is Linux GPIO .h, so it provides function for GPIO operation, such as GPIO 13 in this code. The next is Linux delay .h, which is includes the msleep, like delays in milliseconds delay. Linux kthreads .h is provide function for managing kernels threads. So next is global variables, static integer GPIO number 13, which is the pin in number 13 on the board, which your LED is connected to the port. Next is static shrug task shrug multiply thread. Static pointer to task shrug, which represent a corner thread. This will store the thread created to handle LED blink. The third one is blink thread function and the blinking logic. So the purpose of this is runs a counter thread and contain a logic to blink the LED. So static integer blink thread void multiply data is a static function designed to run a counter thread, and the void data is a parameter to allow passing data to the thread, return an integer, and the next line is while that k thread should stop. So this will check if the thread has been requested to stop. So set true when k stop is called. So the loop continues until the thread is stopped, ensuring continuous blinking. The next line is GPIO set value GPIO number 1 is the set GPIO pin 13 to high, which is 1, turn the LED on. So assume the GPIO has been initialized beforehand. MS lib 500, which is both the thread for 500 milliseconds, aka 0.5 seconds while the LED is on. Next line is GPIO set value GPIO 0. So set the GPIO pin to low 0 to turn the LED off. So the next line is still 500 milliseconds delay. So next is blink init function, which is module initialization. Static integer init blink init void. So static limits the function scope to this file. The PR info blink LED module log. So print the message to kernel block viewable with you can use dmax to view it. And next is the RET GPIO request GPIO not LED. So it requests access to GPIO 13, labeling it LED to identification. Return 0 on success or a negative error code. So the next is again. So this the end of my explanation. So the next is the video about how it's work. Okay.
Một lát.
And that
So it's
is all for our presentation. Thank you for listening.